Welcome to the second lecture of Rotational Dynamics. In last video, we have studied what is meant by circular motion, rotational motion, difference between them. So in this lecture, we are going to move further. Motion can be classified into various factors depending upon the path. Motion can be rectilinear motion if that object is following straight line path, or curvilinear motion if that object, suppose this is the object, if it is traveling in a straight line, then it will be rectilinear motion. If it's going to be change its direction, so it will be curvilinear motion. Curvilinear motion further divided into various type of motion. For example, if object is following circular path, that type of motion is circular motion. If object is following elliptical path, then that type of motion is elliptical motion, and depend upon the various geometric shape. For example, this would be triangular, this would be rectangular, and so on. That type of motion can be classified according to their geometric shape. And we are studying circular motion in detail. Depend upon the speed, circular motion can be divided into two things: uniform circular motion and non-uniform circular motion. Let's consider an example of a fan. When you are going to switch on the fan, the speed of the fan goes on increasing, or speed of particle of the fan goes on increasing. After switch on the fan, speed of the particle of the fan will going to be follow the circular path. Its speed will going to be increase. It will increase up to that point when it will reach maximum speed of it. After that speed, fan will going to move in a constant speed, and that motion is known as uniform circular motion. What does that mean? That during the circular motion, if speed of particle remains constant, it is called as uniform circular motion. Here in this case, that after reaching that particular speed, its maximum speed, blades of fan will going to move in that speed along the circumference of circle. During the circular motion, if speed of particles remains constant, is called as uniform circular motion. You can simply write uniform circular motion as UCM. U stands for uniform, C stands for circular, and M stands for motion. In this case, magnitude of velocity is constant. What is that? Magnitude of velocity, which is nothing but speed, magnitude of velocity is constant. So whatever particle which is performing circular motion, so speed of that object or particle will be constant. Only direction of motion is at every instant is changing. For example, this particle, instead of following rectilinear motion, at every instant it changing its direction. So only direction of motion in uniform circular motion is changing in such a way that velocity is always tangential to the path. Whatever the particle is performing circular motion, at every instant it is changing its direction. So velocity will be tangential to the path. If I am considering particle at this point, velocity will be tangential to the path. So uniform circular motion is nothing but the speed of particle remains constant, magnitude of velocity is constant and velocity is tangential to the path. Whatever kind of motion it will be, whether it is rectangular, triangular, hyperbolic, parabolic, if speed is constant of that particle performing motion will be uniform motion. As we are studying circular motion, that's why we are using word uniform circular motion. Velocity is nothing but speed in given direction. So as direction is changing at every instant, it means velocity is changing, and whenever there will be change in velocity, that body is said to be accelerated. The acceleration responsible for UCM is centripetal or radial acceleration, and it is denoted by vector AR. Here suffix R stand for radial and A stand for acceleration. So this term is used to define radial acceleration. So as the direction changing at every instant in circular motion, so that's why that acceleration is known as centripetal acceleration. Centripetal acceleration causes change in direction, and it is given by vector AR equals to minus omega square vector R. As you have studied in previous classes, that centripetal acceleration in terms of magnitude is given by v square by r, and you have analogous relation between translation motion and circular motion. What is that? Linear velocity is equals to angular velocity into position vector r. So when you are going to substitute v, which is equals to omega r in this case, what you will get? Vector AR is equals to omega r bracket square by r. So this will be omega square r square divided by r. 1r will going to be cancelled. So you will get omega square r, which is nothing but this relation. So in terms of magnitude, it is equals to v square by r or omega square into r. Here negative sign stand for that in circular motion, r stand for the particle, how much that particle is away from the center, and it is away from the center, while centripetal acceleration is toward the center. It means direction of centripetal acceleration will be along the opposite to the vector r. That's why the term here is negative, as it is opposite to the direction of position. You can simply say along that centripetal acceleration AR is along negative of vector r or opposite to the vector r, or AR is opposite to vector r. When you are going to use opposite word, you don't need to write negative sign. If you are using along the vector r, you have to use negative sign. So this is nothing but uniform circular motion. And when fan gets switched off, its velocity goes on decreasing. So what does it mean? When fan is switched on or off, the speed of particle of the fan go on increasing or decreasing for some time. However, their directions are always tangential to their circular trajectory. Means when you are going to switch on, it will going to be increase in velocity, and when you are going to switch off the fan, it will be decrease in velocity, and the direction of velocity will be always tangential to the path. So during this time, it is called as non-uniform circular motion. What does that mean? during circular motion, if speed of particle does not remain constant, it's called non-uniform circular motion, as we have studied in example of fan. While fan gets switched on, speed will going to be increased until its speed will going to achieve constant speed, and after switching off, speed will going to be decreased. So during that time interval, it will be non-uniform circular motion. So in this case, magnitude of velocity will not be constant. Magnitude of velocity is not constant. As we have studied in circular motion, of uniform circular motion, magnitude of velocity is constant. In non-uniform circular motion, velocity is not constant. But direction of the particle, direction of that object is still changing. That's why it is performing circular motion. Direction of motion is changes. Therefore, due to this, velocity is still tangential. The change is only in the magnitude of velocity, and therefore centripetal or radial acceleration still there, just because of there is a change in direction. So the acceleration responsible for changing the magnitude of velocity is called tangential acceleration. Write down this in your notebook, that acceleration responsible for changing the magnitude of velocity is called tangential acceleration, and while that of the acceleration responsible for changing the direction is radial acceleration or centripetal acceleration. As magnitude of tangential velocity, that is vector v, is changing during the non-uniform circular motion, the corresponding angular velocity vector omega is also changing. So due to that change in velocity, there will be change in angular velocity. So that relation can be given by vector v is nothing but vector omega into vector r, or in terms of magnitude you may write v is equals to omega r. So the change in angular velocity can be given by omega is equals to v by r. This is due to the angular acceleration. So that change in velocity is due to angular acceleration denoted by alpha. So alpha stand for angular acceleration. Acceleration is nothing but rate of change of velocity with respect to time. So this is angular acceleration, so it will be rate of change of angular velocity divided by time. So what is that? Rate of change of angular velocity with respect to time. So that alpha will be given by d vector omega divided by dt. This is nothing but differential form of alpha. As studied example of fan, though the motion is non-uniform, the particle are in still the same plane. Suppose this is the blade of fan. So when it's going to be rotate, the particle of fan will be in same plane. It is not moving like this. So that's why the particle will be in same plane. Hence the direction of alpha is still along the axis of rotation. So that direction of alpha is depend upon the speed. What does it mean? For increasing speed, it is along the direction of omega. By right hand rule, we have studied the direction of angular velocity. That suppose if this is a particle performing circular motion in anti-clockwise sense, so to find the direction of this thing, you have used right hand thumb rule, in which you have curled your finger in sense of rotation, and thumb give you direction of the omega. So for this case it was like this, so this will give you direction of omega. Now to find the direction of angular acceleration, if the speed is increasing, what I am saying that if speed increasing, direction of alpha will be, so vector alpha will be along angular velocity. For increasing speed, it is along the direction of omega or angular velocity. And consider the second example in which that particle is performing circular motion in anti-clockwise direction. Okay, doesn't matter whether it is anti-clockwise or clockwise. Direction of, as it is anti-clockwise, so direction will be given by this direction of angular velocity. But consider in this case that speed is decreasing. So in this case speed is decreasing, so direction of angular acceleration will be opposite to that of angular velocity. So what is that? The speed, it is, so during the speed is in decreasing, it is opposite to that of vector omega. That's it. In case of only angular velocity, you have used right hand thumb rule. If it is in moving in anti-clockwise, so direction will be in this case along the axis, and if it is anti-clockwise, so it will be downward direction. In case of alpha, what you have to remember is speed is increasing, it will be along the angular velocity, and if speed is decreasing, so it will be along, it will be opposite to the angular velocity. So up to this we have studied that circular motion depends upon the speed. It is divided into uniform circular motion and non-uniform circular motion. If during the motion, if speed is constant, that type of motion will be uniform motion, and if speed is not constant, so that will be non-uniform motion. As it is following circular, so that's why name is uniform circular motion and non-uniform circular motion. In uniform circular motion, speed, that is magnitude of velocity, is constant, and in non-uniform circular motion, magnitude of velocity is not constant. And what we have studied? That acceleration responsible for change in direction will be radial acceleration or centripetal acceleration, and acceleration responsible for change in magnitude will be tangential acceleration. And that expression is given by this, that AR is nothing but omega square r, and here alpha will be equals to rate of change of angular velocity with respect to time. So just because of this, both are different mathematical expression, just because of here magnitude is constant, only direction is changing, and here magnitude is changing. That's why we are considering differential form. Now let's move toward that what kind of force acting, what kind of force is responsible for circular motion. Acceleration responsible for circular motion is centripetal or radial acceleration, which we have studied. That is nothing but what? Centripetal acceleration, denoted by vector AR, and it is given by minus omega square vector R, and the force responsible for this will be given by, you can say that centripetal force can be in terms of short term, you can write C P F, centripetal force, and that is given by CPF is equals to, as you know that by Newton's law, that force is nothing but mass into acceleration. So here acceleration is centripetal acceleration, and as we are writing in vector form, so you can write m vector AR. When you are going to substitute the value of this, you will get minus m omega square vector r. Here negative sign indicating that force is toward the center, because centripetal stand for center seeking. So that type of force will be centripetal force, and mathematical formulation will be given by this. Or you may write it as, when you are going to substitute, as you know that V is equals to omega r. So when you are going to substitute omega is equals to V by r, you will get minus m V square by r. Or you can get alternative equation m V omega. So depend upon the quantities given in numerical, you can use one of this. Okay. So in terms of magnitude, there will be no any vector symbol there. So centripetal force is a resultant force, means whatever kind of force will act on that body which is performing circular motion. But the thing is, consider a merry-go-round. If you know that thing, when you are in merry-go-round and if someone is giving force, so you will feel that you are performing circular motion, and during that you will feel some outward pull. Until you will reach that maximum speed, you will feel that there is something that causing your body to move outward of that merry-go-round, and that feeling is nothing but that force which is experienced by your body while performing circular motion, and that thing is known as centrifugal force. So this centrifugal force is not a real force. We can call it as a pseudo force arising due to the centripetal acceleration of the frame of the reference. So it is not a real force, but not an imaginary force also, because you are really experiencing outward pull. And this type of force you will observe whenever you are performing circular motion. And this can be represented by, if body is performing circular motion as we have studied earlier, so this is what this will give you direction of position vector r, and the force, if we are going to consider only the force, so you will find that centripetal force will be toward the center of the circle. Means what? That CPF, direction of CPF will be in this direction, and while performing that circular motion, that body will going to feel that outward pull. So that's why this direction will be given by, the direction of outward pull will be given by this. So this one will be, in this case, this one will be CPF, which is nothing but centripetal force, and the resultant force, that action according to your Newton's third law. So this force will be action force, and Newton's third law say that if there is an action, so there will be equal and opposite reaction. So that reaction is nothing but centrifugal force. So direction of centrifugal force will be in this. CFF will be stand for centrifugal force. So you have symbol negative for CPF and positive for CFF, because our reference is nothing but position vector, that is vector r. So as vector r is away from center of the circle, so that's why negative sign will be given by centripetal force, because it is opposite to the vector r, and positive sign will going to give by CFF, because it is along the vector r. So it is given by centrifugal force can be given by CFF will be equals to plus vector MA. In earlier case we have given negative term. Okay, so you may write this as a m omega square vector r. So what we can conclude that CPF will be given by minus of m omega square r and CFF will be given by plus m omega square vector r. Magnitude of both will be same, just because of they are equal and opposite forces. So centrifugal force is not a real force, it is experienced by the body. That's why it is not imaginary force. So there are two ways of writing the force of equation. So what are the two ways you can consider? That in terms of if you are considering centripetal force, because in various cases you might be not able to find that what kind of opposite force you are experiencing, or might be in some cases you are not able to find what are the force is applied. Maybe you can find what are the force you are experiencing. So depend upon the situation, there are two ways of writing the force of equation. Your first will be if you know the centripetal force. Centripetal force. So for that factor you can write resultant force is equals to minus omega square vector r. So here resultant force of all the real forces, which means centripetal force. And you can write in terms of centrifugal force, it can be given by m omega square vector r plus real force will be equals to 0. So these are the two ways by which you can write equation of motion. In next lecture we are going to study application of these forces, I mean centripetal force and centrifugal force.